Hello guys, my name is Mpmc Gopal. My roll number is EC222B1103. Our batch number is 53. We are here to present our course project, Microprocessor and Controller.
And my name is Kenendra, by EC222B1120. Here we'll start our project explanation throughout the slides.
This is a course project of microprocessor and microcontrollers titled Heater Alarm, which was developed by using a PIC microcontroller. Let us go into the slides. In the ancient time, people used it to measure the temperature of the atmosphere using this instrument, and later on people further developed and made a thermometer which consists of mercury. When mercury absorbs heat, it raises the temperature and temperature is measured. When technology came and gave a revolution to the industry, they developed a product to measure the temperature of water. This is the product. These kind of products are usually used in the mine industry to measure the inside temperature of the mines. These products are used to measure the temperature of our day-to-day life objects or instruments like computer, phone temperature. And let us start with our introduction of our project. Our project will point about the heater alarm system which aims and ensures safety of the user. The outcome of the project is we will aware the people how important is monitoring temperature and detecting malfunctions or providing timely alerts to the user. By implementing this project, we can prevent potential hazards and explosion of the geysers, etc. A heater alarm utilizing a PIC microcontroller constantly monitors the temperature of the heater or any surface component. This is the project how our project works. Set a predefined temperature in the which we are going to insert in the PIC microcontroller, and we'll connect a LM35 surface temperature sensor. When we'll bring a temperature to the near to the LM35 surface sensor, if it observes the temperature is exceeding the predefined temperature, it gives signal to the PIC microcontroller, and the PIC microcontroller initiated the and rings the alarm, and simultaneously it shows the temperature inside the LCD display. The components which we are going to use in our project. This is the 16:2 LCD display and a buzzer and a temperature sensor LM35, PIC microcontroller and a potentiometer, reset button and resistors, battery, crystal oscillator and a dip IC. Working principle of these components. 16:2 LCD display. It is used to show the information of the temperature on the screen. Buzzer. It is used to alert the user by providing a beep sound. Temperature sensor LM35. It observes the temperature from the substance and sends to the PIC microcontroller. Potentiometer. It is used to reduce or increase the contrast of the LCD display. Reset button. When reset button is initiated, it initializes the system to the original state. When all registers in the PIC microcontroller are cleared. Resistors. Resistors are the passive element, two terminal elements. It is used to reduce current flow. Battery. Battery is used to give power to all the components for working. Crystal oscillator. It provides accurate timing signals for the microprocessor. Tip IC. Tip IC is used to regulate the power because our HW battery is 9 volts. Our PIC microprocessor works at 5 volts. If we directly connect our HW battery to the PIC microcontroller, it short circuit or it may damage. To prevent this damage, we use a tip IC to regulate the power service. The first general paper includes the information about the heater alarm and the importance of monitoring temperature. The paragraphs in these general papers tells us the temperature control system in homes, especially for the areas occupied by the infant and storage spaces. The second paper traces the history of automated temperature and control systems and highlighting the limitations of current systems, including need of manual adjustment and challenges for disabled individuals. Paper introduced an automatic room heater control system using a microcontroller and the temperature sensor to maintain the desired room temperature without human interaction or emphasizing simplicity and cost effectiveness in design. These are the conclusions which we have made after reading the three IEEE journals of the topic related to heat monitoring temperature. The links are provided above.
About using big microcontroller, they are budget friendly, reducing product development costs. If we come to the wide range of operating voltages, the PIC microcontrollers can operate a wide range of voltages, making them more versatile than 8086 microprocessors. Efficiently, PIC microcontrollers consumes minimal power, ideal for battery operated applications. As we come to the abundant resources, extensive online resources and a strong community provide support and development assistance. For a versatility, PIC microcontroller offer a wide range of features and peripherals, allowing for diverse application and functionality. Differences by using 8086 for heater alarm product. The disadvantages of 8086 for heater alarm project. The 8086 microprocessor is outdated, making component sourcing and support difficult. It supports difficult for maintaining 8086 processors of outdated component. Limited processing power. It has lower computational capability, hindering complex algorithm execution. The commercial products. Using a heater alarm, there are several products come into picture in our day-to-day life. There are coffee makers, ovens, kettles, etc. We can use for that. As we come to the industrial, heater alarm in industrial settings safeguard equipment by continuously monitoring temperature levels. If the temperature deviates from safe ranges, these alarms activate warning signals and can trigger automatic shutdowns to prevent overheating, ensuring safety. By preventing the equipment damage and maintaining process control and efficiency. To action safeguard equipment from the damage and potential catastrophic failures caused by overheating, ensuring long-term equipment reliability and operational safety. Heat alarm used in equipment protection of monitoring the temperature threshold. When temperature exceeds safe limits, these alarms activate, triggering automatic shutdown mechanics. These preventive action safeguards equipment from damage and potential catastrophic failures caused by overheating, ensuring long-term equipment reliability and operational safety. There are so many number of products that uses heater alarm and the concept is same. The temperature sensors monitors the temperature. If it exceeds the predefined temperature, it alerts the user of in case some cases it auto cut off the product. Own methodology of making the project. First we will collect the required components for the project, then we will attach the components according to the circuit diagram, solder them on the .pcb board so that no loose connections will be happen among the connections. Then we will write a relevant code according to the working need conditions, and then we will insert the relevant code into the PIC microcontroller. The temperature sensor continuously monitors the temperature of the substance and records the temperature, and it sends the temperature data to PIC microcontroller. If the temperature exceeds the predefined temperature, the buzzer will sound and alert the user to prevent overheating and damage. We come to the working principles of the heater alarm. The temperature sensor LM35 detects the temperature of the heater alarm. It amplifies the signal from the temperature sensor. The PIC microcontroller reads the amplified signal from the temperature sensor and converts it into a digital value. The PIC microcontroller compares the digital value to the temperature threshold. If the digital value exceeds the temperature threshold, the PIC microcontroller triggers the alarm output. The controller also displays the temperature on the LCD display. The reset button can be used to reset the alarm if it is triggered. Heater alarm projects can be used to monitor heaters and prevent fires and other accidents. The use of 16:2 LCD display, buzzer, temperature sensor, LM35, PIC microcontroller, LCD contrast regulator, and reset button, and 10K ohm resistor and battery allows for a simple and effective heater alarm system to be designed and implemented.
This is our project heater alarm, which works with a 9-volt HW battery. To make this project, we need a 25-volt 1000 microfarad capacitor and a regulator because our PIC microcontroller works at 5 volts, but our battery is 9 volts. It may damage our PIC microcontroller if we attach directly to it 9 volts, and a reset button to reset this process, and a crystal oscillator because it a crystal oscillator which is connected to 11th and 12th pin of the PIC microcontroller. It is used for the delay process, and a regulator. It is used for to adjust the contrast of the LCD display, and we are using a temperature sensor to collect the temperature of the substance, and a buzzer. If it temperature exceeds the predefined temperature, it will show the temperature in the LCD display and it activates the buzzer. Let me demonstrate our working project. Further enhancement and references. Our project further development. We are thinking to integrate this project into real-time use or idea. Generally for small babies, their parents use it to bath them with lukewarm water. If we integrate this with real-time water heater, it will alert the people so that the water will not boil at the above required temp. And instead of the buzzer, if we can add a switch, it acts as the auto cutoff for the heater, and it will cut off the temperature. It will it will cut off the electricity to the heater. These are the references which we have used for the project. Thank you.